Maybe we can get like a multi.
I guess the whole premise of this panel is also a good follow-up from the last panel, which was Cambrian explosion of rollups, how there are so many rollups popping up. I think there is a tension in the rollup world because it's where the most innovation is being done, at least in terms of stacks and some of use cases in the Ethereum ecosystem. And there's this tension of pushing the boundaries of what you can do in Ethereum while still maintaining decent amount of interop so that you don't fraction the network effect of the Ethereum ecosystem, which is arguably the most potent tool that we have. And so, oops. This is kind of the point of the panel. Can rollups unite to lead the innovation? What kind of innovation can rollups do? And this is what we're going to explore. So, my first question is, Yoav. Oh no, my bad. Can everyone take just one sentence to introduce themselves?
Oh yeah, I can go first. Hi guys, my name is Patrick McCorry and I work at the Arbitrum Foundation. I was initially hired at the foundation to do research and education, but for the past year it's really been focused on the DAO and governance, and now hopefully building up a tech team to go back to my original job. So that's me in a nutshell.
Hi, I'm Yoav Weiss from the Ethereum Foundation, working on security research and account abstraction, but also quite involved in the L2 ecosystem.
Hi, I'm Mark, and I'm a contributor to the Optimism Collective. I'm here to, grow usage of blockchains and make the super chain super.
Hi, my name is Avihu. I work at Starkware for 6.5 years now.
An OG. Hello, my name is Toghrul. I don't know, what do I do at Scroll? I just complain about things, that's mostly what I do.
Scroll contributor.
Not really, but yeah.
Okay, so I guess Yoav, you can kick it off. Who is driving the innovation today in the Ethereum ecosystem? I guess there are two types of innovation, right? Innovation in features, but also innovation maybe in rollups. So who is driving it?
So I don't think there's a simple answer for that. There's no one, it's decentralized at the innovation level as well. But I think we could do a lot better, and that's through layer twos, because currently a lot of the innovation happens on layer one and then just gets cloned into layer twos, especially in the EVM ecosystem at least. So it's for these. And a part of it is for feature parity. Part of it is also just because people fork existing clients like Geth. So it's we have the RIP process, which is meant to make it easier for layer twos to start innovating separately and have maybe an adjust EVM for their needs. So I expect innovation to happen in both places.
Okay.
Maybe I can jump in as well. So, for the past 10 years in Ethereum, we have this monolithic code base where it was very hard to change Ethereum to do something interesting. So one example is back in 2018, there was a movement to get WASM into Ethereum and it completely failed. It just was never going to get in. So in my mind, innovation comes from the modular stack, execution, data, and storage. And there's so many startups focusing on those different angles. So a lot of rollups focus on the execution part of it. You have these data availability layers focusing on the data. And storage, well, I guess it's more like a node software at the moment, that's a bit more nuanced. But generally speaking, most companies today are doing some type of innovation, and now there's a chance where it can actually get used with less friction than before.
And what risk of fragmentation, how damaging could fragmentation be as a result of every single actor innovating very fast but on their own? Anyone can?
All of them?
There's definitely a sovereignty versus kind of, compatibility trade-off here. And right now the pie is really small. And there's a lot of risk in making huge changes from L1. If you start adding new precompiles, then your code no longer is portable between L1 and L2, and then you're kind of bought into that ecosystem. And then if you add a new opcode, now you need to fork the Solidity compiler and implement it there. And all of this is just like a lot of work. And this is what holds back, changing and adding new features to L2s, because there's like a lot of risk. And I think that while fragmentation of liquidity is a problem, ultimately different projects are going to innovate in different ways. And ultimately we cannot just all stick to the way that L1 works. We kind of all need to explore different design spaces because we don't know what is best. But we need to grow the pie a lot more so that we can get developers bought into each ecosystem that is innovating in a different way.
Can I just say something on the previous point and the first one? I think that, if I think what value is there in L2s, what is the motivation, then I see three things that are relevant for Ethereum. And it's like two things, and then the third one is on top of the other two. So one that we are very used to think about is scalability. We say we want more capacity to the network, more users, and the one way to achieve it is really to execute many L2s on top of the L1, right? And that's what we are already seeing today on existing live L2s. The second one that we started to talk about over the past year more and more is this point of expressibility. You want to, the base layer gave you some things in the protocol, and then L2s are iterating on a bunch of other new expansions, right? New languages. Maybe you want to write in Rust, in Cairo, in Stylus. I probably forgot 5 other different VMs. Maybe you want the expressibility of those languages. Maybe you want to add some additions to the protocol, such as account abstraction or different types of data availability than what exists on the base protocol. All those things are things that are in the works, and they don't necessarily give scale. They also give different expressibility for developers to use. And then on top of that, the third mission eventually is that the good stuff, even if it can mean better ZK technology to prove the L1, it can mean better VMs to prove ZK VMs, and it can also mean better account abstraction or different type of languages to be included in the L1. This is for the L1 to decide, but the L2s are pushing exactly this type of innovation into the L1. And our responsibility and mission also produce those things. So fragmentation is great for this, right? We can't have one player iterating on all things. It's much more efficient if a lot of players are trying to push what they think is best, and then the greatest ideas can also be incorporated later.
What do you think is the responsibility of rollups in making sure that this stays for UX interoperable? Do you think there's a responsibility for governance to say, okay, we have a new VM, but actually we don't want users to see it. We want devs to have more expressibility, but you wouldn't want users to say, oh, I need to do so many things to go from fuel to movement to Starknet to scroll.
I think it's a combination of many people whose responsibility it is. I think to a certain degree, for example, if it comes to validating bridges, there's a bit of a responsibility on EF to make sure that we all coordinate and have a certain standardized API. Because at the moment, one of the problems that I see, if you want to build a real multi-chain app or a multi-chain wallet, you essentially have to go through every single Rollups documentation and understand how the bridge API works, and then build the specific, your specific logic for that bridge in a particular way. Whereas if it's a standardized API for every chain, or let's say every major chain, then the problem becomes much easier. Also, I think certain responsibility falls on the wallet developers, etc. Because at the moment, if you use something like MetaMask, Closer, okay. If you use something like MetaMask, for example, especially for a newbie, having ETH on 3 different chains will look so confusing, and it's difficult to explain, oh, this is how it works underneath. And the problem is, it's not really a technical problem. It's just a problem of creating abstractions. And to a certain degree, it's also our responsibility of L2 builders to create abstractions for people to interact with VMs, etc. So let's say if we want to support other language that EVM doesn't support by default, but it's popular otherwise. Let's say we want to support Rust programming in EVM. It's our responsibility to build it. Or like Starkware has spent quite a bit of time before. I think it was Nethermind who built the Solidity to Cairo transpiler.
And now we have Kakarot. So
Now it's Kakarot. So I think there's a lot of shared responsibility by a lot of different participants in the community.
Okay. I guess I'll ask Yoav. You've been quite involved in L1 governance, you'd agree? You've been involved in L1 governance. What do you think L2s, because we just mentioned syncing or like governance, what do you think L2s could learn from the way L1 has been doing governance so well, or not so well, actually?
So actually not that much involved in governance. Maybe I'm not...
I mean, like going to the research and all core dev calls and arguing about new standards. For example, you've been mostly focusing on account abstraction. So 4337 is arguably the least worst solution that was available back then, and it's evolving slowly to become like a good standard, right? So everyone is breaking compatibility. So they're doing the reverse of the 4337 mentality.
Yeah, so that's so this pertains to the previous question about fragmentation. That's so. Can you hear me? Yeah. So this pertains to the issue of fragmentation, because on one hand you want to innovate by innovate fast on layer 2s. But on the other hand, if you start fragmenting, and account abstraction was the best example of this, if you want to make it more efficient, 4337 uses the lowest common denominator, so it's an ERC, you can use it on every network. But then you see some rollups implementing a version of 4337 that is more efficient because it enshrined in the protocol, but also non-standard. And then you get fragmentation. For example, you see wallets. You start seeing wallets that only work on one or two chains, and the user needs to maintain multiple wallets. That's not a good UX for the whole ecosystem. So I think the balance we need to strike is that layer 2s should innovate and should innovate independently, but try to standardize at the interface, at the API levels. So I think that the governance between layer 2s should focus not on the implementation, but on the mostly on the interfaces, making things compatible for users and as much as possible for developers. That's not always possible. For example, if you implement WASM contracts in Arbitrum and you don't have WASM on another chain, then you can't really abstract that away. But at least for users, you should be able, for example, in account abstraction to have the same transaction type, or if you have multi-dimensional gas. Now, another important example that we should probably consider is around bridging and proving layer 1 state, having the single source of truth. Currently, each rollup has its own precompile or some way to expose layer 1 root or to have a canonical bridge. And building on top of that is complicated and led to many security bugs. So I think we should at least standardize things like that to enable better bridging and key stores.
One major problem that I see with L2 governance versus L1 governance is that L1 as a project has kind of reached this escape velocity, right? I feel really confident that Ether as an asset will exist and be valuable in 5+ years. For L2s, that's not the case. L2s are still fighting for survival. We're not sure which L2s are going to be around for a really long time. And because of that, it's really hard to, have long-term thinking. All the L2s are stuck kind of thinking and making short-term decisions, just trying to literally survive. And to fix this, we need to really grow the ecosystem, the number of users, by 100x.
Yeah, maybe I can jump in as well, because I have a little bit of experience with L1 governance just by being around for too long. I think there's so when it comes to L1 governance, we normally call it rough consensus on how we agree to changes to the network. And the reason why it's called rough consensus is because no one wants to take, I'm trying to think of the right word for this, leadership to decide if the upgrade should happen. So it's a bit like a hot potato. You know, I pass a hot potato here, he passes a hot potato over there, and the hot potato keeps going around, and eventually we're like, oh, we all sort of agree this should happen, but none of us actually made that decision. You know, that's sort of like L1 governance in a nutshell. But what's really nice about layer 1s in particular is that layer 1s can fork. So who remembers, you know, Bitcoin versus Bitcoin Cash, Ethereum versus Ethereum Classic? What's really nice is that L1s can fork. They can have two different communities, two different visions, and go their separate ways. I remember back in 2014 during the Bitcoin block size wars, I think it was Gavin at the time, he made the comment to say, well, if Bitcoin forked, it would plummet and die. Where actually in the end, they forked, and actually the market cap for both was worth more than, you know, the market cap of Bitcoin prior to the fork. So actually forking is also a strategy of allowing communities to go their separate ways, resolve conflict, and hopefully, you know, both of them can survive long term. But as we've seen, I guess, over a long enough time period, you know, one currency does win. So Bitcoin won, Ethereum won, but the other two still linger and they'll always exist forever. So the reason why I make that distinction is because in layer 2s, you don't have that privilege. You have this bridge that lives on the network, so in our case, it lives on Ethereum. It's holding billions of dollars, and there's no way to fork it. You know, the entire community has to reach consensus or agreement that if an upgrade happens, that it happens. And if you disagree with the upgrade, well, you're stuck with it. You know, it's going to pass, it's going to get approved, it's going to get executed, then everyone will be forced to upgrade. It's very difficult to resolve conflict if there's two different visions. Your best approach is to wait for the upgrade to happen, or take your funds out prior to that, and then go launch another L2. You lose this nice frictionless, conflict resolution, and so it will lead to more heated debates long term. Although right now everyone's really nice and friendly in governance. But, a couple of years down the line, it's probably going to get more heated as people really care about technical vision of how the software should evolve. That's like a slight difference.
I just wanted to add regarding L1. So this used to be true that L1 has this rough consensus and community can split, four can just go their separate ways. I'm afraid it's no longer the case due to DeFi. If you have USDC as a collateral, you have an external collateral, and now, let's say someone wants to fork Ethereum, which we almost saw people trying with ETHPOW during the merge. But then, but it's hopeless because if Circle chooses to stay on one side of the fork, that's the only one that's going to survive. So in a sense, we lost that capability.
But I think that's really cool, though. Like, this gets to the heart of governance. So an L1 is becomes more like a power play, as you say. If Circle doesn't move, well, what's the point of your new fork? Because all the USD, collapses, DeFi collapses. So it's, it's really interesting how L1 is very much like power plays, and what are people going to do, and who are the kingmakers in that decision. So yeah, it's really, really interesting, field of research anyway, or at least to live that experiment is very interesting.
Right, so I guess you touched on governance, so I'll ask Mark, what's your favorite thing about the way the Arbitrum DAO operates? And then I'll ask the opposite.
I think the on-chain execution is really cool. I think that, that's really, really like the vision for a DAO. So one thing that Arbitrum has that, Optimism doesn't have is the ability to automatically execute any proposal through the DAO. And, I think that this is a vision that all L2s should eventually move towards.
Right, so Patrick, what's your favorite thing about the OP DAO, or the OP governance process?
I mean, this is really easy. I think what's really good about OP governance is, one, there's a dedicated team that's trying to, bring actors together, the advise on the governance and towards upgrades, but also retrospective funding. I think that's been really good. I was also an OP recipient of retrospective funding about a year ago. I think it's a really good way to target people in the community, like real people, give them a grant, and that will actually then help them get involved in governance. Because once you get some tokens, well, they're governance tokens, you can delegate that, and it actually gets you intrigued about, oh, I should go get involved now. And actually being able to target people in that way, it's really, really good. One way you decentralize governance is by giving as many real people as possible some tokens and making sure that, oh, you do have a say in this governance system. And I think retrospective funding does a very good job of that.
Okay, nice. Moving to another topic about like innovation in terms of what like the stack itself. So not only governance and getting agreement, but new ideas of how to make users more empowered. And Avihu, so I'm going to be a bit of a fan here, but you did kind of design validiums, and then you also had aggregation of proofs 4 years ago, or like. So I would go as far as to say you saw some trends in advance. So how do you see the like rollups move toward and like some kind of software that will empower users more in the next years? Can we pick your brain for some vision on like what we should build as well?
I think first of all, we did it. I mean, at least in the Starkware, but probably in even the broader form of all everyone who execute on Ethereum. And I think I've seen somewhere, so I very much share the feeling like that I take off my hat for everyone involved so many years in research and development on Ethereum. So really, cheers for all of us. Yeah, I think right now, what is the hottest topic for us, maybe? Well, I think we will still go back later on to data availability. I don't think we necessarily ended there because the ability to work with different types of data availability will also serve potentially different needs, like working with different storage in different places that have different security, long life or short life needs, and so on. But I think right now the thing that we are putting the focus on is mostly on, there are a lot of ideas flowing on how you can get fast finality, fast proving, because it is a requirement for a bunch of things that are being put forward right now. You mentioned interoperability, based rollup is something that is coming. So all those things, if you want like very good user experience, you probably want to handle very, very fast confirmation and proving following that. So one thing that I do see a lot of interest at is basically how do you move from very slow block proving to a very fast one, and not just stay on the L2 space, but also move it to the L1. And how do you utilize proofs in all kind of other aspects of the L1 right now? And I think Vitalik was talking about that in various places in the past 2 or 3 days. And this is like right now a live and ongoing discussion about how do we do that. How do we incorporate things like very fast proving technology, such as using Starks in the base layer, where it can bring value and so on. So that is like one area of research, which I admit is not very close to me. I'm following it very closely, but other people are the ones who are progressing it. Another thing that I personally am interested at is the ability to work for an L2 to work on various places, interact with other L2s or even with other L1s. And there I think I'm a bit more involved, and I feel this is a very virgin, unexplored territory to some extent. So I don't have anything too exciting to say right now, but definitely looking into that.
Okay, cool. One other topic we've seen, like Justin Drake, other people like touch on, is based rollup. I'll go to Toghrul because he sighed. So do you think it's just too early or just a wrong narrative to push? We should go for like more simple problems, or like BFT for L2s is fine?
I'm very much in favor of people tackling future problems as well. I mean, not everyone should work on the problem of next week or months. Some should look into like 3 years into the future, right? First of all, I'll say there are probably people who know more about me about based rollup, and they have a stronger based opinion. My initial thinking is that if you don't want to add more trust assumption, and if you don't want to add more data availability, then the way to go there is to be able to really execute on very, very fast proving. Because the only way not to rely on somebody that, or maybe let me just explain in case people don't know what it is, what I have in mind. So if the goal is to have the set of validators on L1 posting L2 blocks to Ethereum and be used as the sequencers of those transactions and those blocks, then at least in the case of validity rollups, you need also the proof of those blocks to arrive at some point. And now you have two options. Either you post all the data needed for the proof, that includes a lot of witnesses that we don't put today on data availability because we don't need to, then you either need to post the proof, either need to post all this data, and then somebody could execute on the proof later, but then it means you pay more data, or you post the proof right away, and then that's fine, you don't need to post the data. But then you really need to be able to work on like seconds for executing large blocks or proving large blocks at the same time. So it's possible with some new technology, or will be possible with some new technology, but we have a lot of iterations to make on that.
Okay.
Should I start with what people claim base rollups do, and then
I like that a
explain
lot.
what base rollups actually do? So, allegedly, base rollups inherit liveness and censorship resistance from Ethereum. That's a lie. They don't. So the only way you can actually inherit censorship resistance and liveness from Ethereum is if every proposer on L1 opts into sequencing L2s and has access to the mempool of L2s. Because otherwise, if you don't, you still trust someone to provide you with the transactions on the L2. And then on top of that, the idea that every single proposer is going to opt into sequencing every single L2 is also quite far-fetched, let's put it this way. And so you end up with a system that has really slow finality, slow block times, because you can argue that, yeah, you can add like 32 ETH slashing conditions through pre-confirmations. Is that enough for a lot of use cases? I would argue no. 32 ETH security is not enough, especially if you're talking about transactions that can move around millions or potentially billions of dollars. So short block times don't really make sense there, so that's out. Has slow finality, so you need to add a BFT consensus protocol to actually have fast finality. And what do you end up with? You end up with a rollup that has kinda Ethereum security and liveness. It doesn't, but let's assume that it does. But you still rely on the consensus protocol to enforce pre-confirmation and preliminary ordering. At that point, why would you even use it? Because especially for ZK rollups, then you get another problem. Because the proposers are separated from provers, you have to think of a way to distribute the incentives between the provers and the sequencers. Whereas if you're doing sovereign sequencing, let's say you run your own consensus, you can combine the role of the prover and sequencer and just have one person both submit the proof and sequence the transactions.
I mean, I can make a comment there. Oh, sorry, you go, Mark.
I'm a big believer in talking about things in terms of the value added, the problems that are being solved for users, rather than speaking in terms of technology, right? Like, that's one major problem with this industry. We're like, oh, we have this crazy technology, it's so good, but no one really understands like what the actual value proposition of that technology is, right? So as an industry, we need to evolve in this way and speak about benefits to the users, right? So based rollups, in my opinion, make the user experience worse.
Yeah, I'd agree with that. I mean,
Do we have someone on the panel who thinks it's a good idea?
I can act as Justin Drake. So what about shared sequencing and atomic synchronous composability?
Another pipe dream? I don't know. I think the whole idea of like, oh yeah, let's separate L2s because we want the L1 to be lightweight to validate, but then, oh yeah, let's add shared sequencing and make every single proposer validate every single L2. At that point, just like build Solana.
well, I mean, I can make one comment there on shared sequencing.
Doesn't work that bad.
Yeah. I mean, for
Well,
me, okay.
sorry.
Joking.
You have your, go.
Oh, no, I was just saying, like, if you want composability between every single L2, atomic composability, then you need to run all the full nodes unless you have real-time proofs, which, I don't know, maybe somebody thinks that they're going to be there in, like, a year, but realistically, probably not going to be there in a few years' time. So, basically, yeah, if you're a shared sequencer, you need to run full nodes for every chain that you compose with.
Yeah, so maybe just on that, I want to get this one small point, and it's for search sequencing, I've always looked at that as a bit like WordPress. So has anyone here used WordPress before? Any WordPress users, look at that. And I assume you use WordPress because you wanted, like, in our case, block space. You wanted somewhere to do your work, but you didn't want to run the infrastructure. You just wanted to launch something, do your writing, publish it, and that's it. That's all you care about. To me, that's search sequencing. You're going to have these RAS providers or service providers who will take care of all the infrastructure for you. You focus on developing your game and you deploy it there, and they run everything for you. And then they're just naturally going to be in a spot where it's like, oh, I'm running 20 different rollups. Well, now I can just share the sequencing between them. So to me, that's how, in my mind, I see search sequencing evolving. It's just for the case where someone doesn't want to run their infrastructure. But I think we make too big a deal out of it, to be honest. It's
But just to add there, when I was criticizing shared sequencing, I was specifically criticizing that in the context of L1. I think in case of rollups as service, etc., I think it makes sense because, especially if you think about application-specific rollups, if let's say I want to launch a game, I don't really want to bother with all the infrastructure stuff, etc. I would just want to outsource it to somebody else to do it for me. And then if that person is already sequencing 15 different rollups, they might as well support you as well and share have atomic composability with other rollups in the stack.
So, I think I share your skepticism about this direction because I'm not sure about feasibility. I mean, having to be a full node of so many chains. Now, the reason to still explore this design space, try to solve this problem, is that there is a strong incentive for actors to do shared sequencing for cross-chain MEV. So if we don't get it right at layer 1 and at least help keeping it decentralized, it's going to happen anyway, but it's going to happen through centralized services or through networks that are not necessarily good for things like censorship resistance across different networks. So it's a worthy goal. I'm not sure it's achievable, but it's worth trying because the alternative is not great.
So I think for a lot of cross-chain MEV, the main MEV that you're going to get cross-chain is mostly going to be arbitrage probably. So I think, and for that you actually don't need real-time composability. You just need fast enough composability where you can beat all the other people who are moving the money to that chain. And for that, I think Ethereum just needs to be faster. If Ethereum is faster, we can, and we have real-time proofs, then we don't actually need shared sequencer. We just compose through the L1.
Yeah, but I mean, taking it to the extreme, I mean, don't you think that if one entity runs this giant node that is a giant node across all the chains, and they are able to produce the next block on all chains, don't you think this would be the most profitable validator by far? Like, it's able to extract MEV from and catch every opportunity. So if someone does that in a centralized way, they are going to win, no?
I think I would agree that just one person building all the blocks together that are atomically composable would be the most profitable strategy. I'm just not sure what will be the difference in profitability, because we talk a lot about cross-chain MEV, but nobody has ever quantified how much cross-chain MEV there is, because it's the same with Ethereum L1. We talk about MEV a lot, but in reality, 8% of the total block of rewards now are MEV, or something 8 or 9%. So it's not that big of a percentage. So, and I'm not sure. Maybe it's big. I don't know. But like, none of us know. We're just speculating, basically.
Okay, nice. Mark, you mentioned bringing more value to users. I guess, are you looking into this like diffused idea that someday optimism will switch to ZK? Like, are you looking into it, and do you see that bringing value to users, or is it not even a problem right now?
That is a great question. I think the first thing we want to talk about is like, what is the value add for a ZK system, right? Because people always talk about, oh, ZK is the future. And then it just becomes this buzzword where it's like, oh, do you have ZK? Like, oh, okay. You know, and then it's like a 500 million, like, you know, Series A. And so, but the real value proposition for ZK, for an L2, has to do with bridging, right? Because the zero knowledge proof is used to basically prove the state of the L2 to facilitate a withdrawal. It could also be used to bridge from one L2 to another L2. So Optimism and the OP stack is currently, you know, set up to enable anyone to deploy a stage 1 rollup. We are currently working on the ability to allow the OP stack to deploy ZK rollups with very minimal code added to the system, right? The idea was we're working on this multi-proof where the proof system is compromised of multiple different proof schemes. And it's modular in this way where we can just plug in more different types of proofs. Right now we have a single fault-proof system based on a program written in Go and a fault-proof VM that runs MIPS32. We're currently working on a Rust program and a RISC-V fault-proof VM. And all of those will be able to like run with each other. Each program can run in each VM. And then we're also working with SP1 and RISC-0 to compile our programs, the fault-proof programs, into these ZK VMs to be able to run them. And then we can just plug those proof types into our multi-proof system. And then the OP stack will be able to operate as a ZK rollup seamlessly.
Did you consider using Kakarot?
To be honest, I really don't know much about Kakarot, but I would love to learn more.
Yeah, cool.
I think you should. I mean, it's more efficient. I just wanted to fix one. Sorry, I just wanted to fix. I know. I just wanted to fix one misconception because I don't think we can leave it to say the main thing that you want to use proofs for is for bridges. The base promise that. The reason this is like a very common misconception is because bridges is like this one place that I really want to know that things are valid at the point where I do the operation and I don't necessarily trust everything. But every time, in every case, and decentralization means this case, or at least for some people, every time you want to run any infrastructure, it doesn't have to be like a full-fledged general L2. It can be any upchain that operates on anything. And you don't want to trust the operator, and you still want to know things are final and what is the state of things after some execution of some transactions, you need to have some method to run something in order to know that. So if I want to know on some upchain I just discovered what is the latest state or some late state of the chain, I want to be able to not necessarily rely on that operator. So either I rely on some L1 mechanism or I rely on proofs. And the ability to rely on proofs enables anyone to know a comparable recent state of the system in a much faster way than it does without proofs. So there is a very clear value propositions to users. Now we can argue, are those users just bridges? Do we have cases where we need not to trust the operator even for the simple user? But it's not limited to bridges.
You're completely right there. So what he's saying is that off-chain infrastructure that's operating as a light client can receive a ZK proof and be sure that all of the computation was done, right? This reduces the need to run a full node. A bridge is just one version of a light client. So if you make it more generic, it is more generically useful. But yeah, overall, that is like a good value proposition for ZK proofs.
Okay, cool. I'm done with my questions, so I'm going to give it to the public for 2 or 3 questions. Okay, 1, 2.
Luca, I can see Luca there.
One last. Okay, I'll pass around the mic. Please keep it short.
Please, no questions from L2 Beat. They're gonna probably grill us all.
L2 beats, sorry.
L2 Beats.
Yeah, thank you for the panel. The Ethereum Foundation is currently leading a project to prove formally ZK VMs and EVMs. I just wondered, is it relevant to do this also for optimistic rollups right now? I mean, on the node parts, is it a good timing? Or because ZK is the future, we should just wait and let you develop before doing that?
I think that right now, ZK is the future, but in practice, it's still very expensive. And I don't know how long it will be until proof generation is cheap enough to really push the transaction costs down.
Soon.
I want to say already there, but let's take like 6 months, okay?
Yeah, I mean, maybe I'll just echo that. I've always been a believer that you're going to have a combination of both, where it's going to be a fraud-proof system, and if you really want to speed up the system, you'll submit a proof. So that way, optimistically, you never have to produce a proof if it's not required. You only do it when necessary, and you'll like the thing that will bring down the cost for users. But right now, like the bisection protocol for the fraud-proof system is good enough until there is a, as you mentioned, not even just even cost-effective, but also just like where it's easy to run as infrastructure. So there's this really nice paper recently by ZK Sync where they try to evaluate 3 different proving systems and they do apples and apples comparison. And in the end, they only did 1.5 because they just struggled to run the infrastructure themselves. And I'm like, that's annoying. I mean, I really enjoyed that paper, but I was like, we're just not at that point yet, even just from an off-chain infrastructure side. Still quite hard to run.
Oh no.
Hey, so I have a question for Mark. You said that every OpenStack chain can be stage one.
Not for Toghrul?
I have many questions for Toghrul. So you said that all the OpenStack chains can be stage 1 today, given that you have released permissionless proofs. But how can that be true when you need $2 million to challenge one state root?
That is a great question. Yeah, I mean, you know, there are capital requirements. It's just realistic. And the same sort of thing exists for all, like even ZK rollups have like to pay the cost for, you know, proof generation and running the infrastructure. I mean, of course, they can like earn those in transaction fees. But yeah, you are right. That is like an existing problem. You know, there's ways to optimize this. We have an open, you know, spec pull request on our, you know, open source specs repository that you can go and look at where we attempt to, you know, reduce the costs. I think it's really important that, you know, we released the first, you know, system and we can iterate on pushing the cost down. Yeah, you're right. It isn't like really easy for anyone that say would deploy a smart contract to instantly have a stage 1 roll up, but maybe if you know, raise some money from VCs, you can have that money. Not ideal, but over time, we'll commoditize it more and more.
If it's about challenging, challenging a fraud, seeing an invalid state change, and now you want to challenge it, is that the case we are talking about when you have to submit a challenge? So technically, since everyone can see, I mean, you can prove off-chain that the proof is going to be successful, and the verification game is guaranteed to end. That's how the protocol is built. Technically, you could even tokenize it. You could even just raise the $2 million from everyone because everyone sees that it's going to win, that you're going to end up winning this dispute.
Yeah,
It's a dangerous direction to take because then people could say, let's also tokenize the other side who is going to take the fraud proofs to win the dispute and share with us the money. He can also fight it. So it's unclear to me where this leads.
I guess the argument is that because it's deterministic, like the other side, there's no reason for you to take the
Yeah,
other
but it can say, okay, I will just pay everyone whatever shares they have except $1.9 million.
No, but I mean, since the result is predetermined, it's not like it's not a popularity contest or or a prediction market.
Yeah, I just treat to the fact that he said, what if no one single entity wants to pay the $2 million? Then I say, it's unclear to me that the economical game ends in that way necessarily.
Maybe it's worth stepping back a bit and just saying, just to the point of your question, why in a fraud-proof system are there bonds to begin with? Like, why should I have to place a bond that then challenge and ultimately, hopefully, protect the system? And that's really just to, one, identify people to make sure it's not a Sybil. Imagine you have like 10,000 challenges, and now as the operator, I got to respond 10,000 times. That denial of service attack could just be overwhelming. And the second one is just add a cost to it, such that if you are a malicious actor and you're willing to put down a bond and try to steal money from the system, you'll like to think they will then hopefully, it's deterministic, you play through the game, and then they lose their funds. That's the purpose for the bond itself, and in fraud-proof systems, as long as the fraud-proof is this interactive game where Alice and Bob has to go back and forth several times, I think you're ultimately going to be stuck with some type of bond system anyway. And what that bond will be is obviously going to be a research topic of how effective that will be. And then obviously in the zero knowledge world, or even a non-interactive world, imagine you have a non-interactive fraud-proof system. I think there you could probably get rid of the bonds because you only need a one shot to prove that it's invalid. It really comes down to that interactive game that the fraud-proof systems have today is why you need bonds to begin with. So I think it's really important to say, why does this even exist to begin with? Going back to the requirements, like what are the requirements for this to work?
You can also take another step back and just say that everyone should use ZK proofs, and then you don't have to deal with bonds or anything.
He says no.
Okay, all right. No questions for me. Done.
All right. This concludes our second and last panel. Thanks to the panelists.
Thank you.